Hello and welcome to the Smooth Scaling podcast, where we speak with industry experts to uncover how to design, build, and run scalable and resilient systems. I'm your host, José Quaresma, and today we had the pleasure of chatting to Chris Nesbitt-Smith, who's a technology strategist and consultant on architectural direction for the National Digital Exchange. We had a great conversation with Chris about his work going all the way back to the early days Kubernetes, and what I really appreciated was his approach to designing and developing systems. So his recommendation is to focus on the business needs and at least look at trying to stay as high as possible in the service stack. If you like this episode, please subscribe and leave a review. It really helps the podcast. Enjoy. Welcome, Chris. It's great to have you on the podcast.
Thanks for having me.
And I would actually like to start straight in with Kubernetes, right? So you have been working, or you started working with Kubernetes quite some time ago. I saw that all the way from 0.4 version in production, right? Can you tell us, actually, when was that? I don't know exactly when the 0.4, I cannot quite remember, cannot quite pinpoint that, but can you tell us how you ended up there and what was the experience?
Well, it was about 1 million Kubernetes years ago and about 1 billion AI years ago.
Yeah.
It was, we were in a government department. We were looking at like how can we roll some of the new apps, and like the UK Gov had a bit of a digital transformation around 2013. So I think this would have been 2014, 15, something like that. I don't know, off the top of my head. But so we had a load of teams that had built all these amazing applications, and we had a reasonably kind of fixed kind of virtual machine provisioning kind of space where actually kind of getting compute when required at the time, bureaucratic processes of stuff. So we're looking for different ways of how you could do that. And we were obviously moving out of people doing lots of Java dev, where you might have ordinarily just gone, well, we'll run Tomcat, and that would be the equivalent of your kube cluster, right? And because everyone was doing the new shiny things of some Ruby and some Node and some other things and Python. It was looking for how could we fundamentally solve just an application deployment challenge and do that in a more ready kind of fashion. So it was very early doors in OCI containers, or Docker as a the predominant one at the time. Very early on Kubernetes. I think some of the members of the team got some kind of contributions into core Kubernetes at the time, and kind of very early kind of feeds into some of that and dealing with some of those things. It was a journey. It was and still is like the least bad option a lot of the time. It's always one of those things. If you were to look back now, when you were to go and to completely design it afresh, the whole API and things would all look somewhat different. I don't think anyone would look at the API, and hopefully no one will be listening will be too begrudging me of saying that there's some weird things and warts in there that you'd probably go, that doesn't make any sense.
And so it's actually interesting that you mentioned that case of how you started using it, because I think I have a similar experience in my a previous job where we were at a bank as well, and the main, not as well, but we were working at a bank, and the main driver there for looking into Kubernetes, and we used the Red Hat OpenShift at the time, was also the bureaucratic process of getting virtual machines to just spin up some new test environments, right? So we actually ended up having OpenShift running and very easy spinning new dev or test environment. It was heavy as hell, right? We had a Oracle database, we had Oracle WebLogic running in containers, and I'm sorry to the Kubernetes gods for that, but hey, it worked, right? It was some heavy stuff, but it reduced things from weeks. It was not technical dependencies, right? But to, I think we went down to around 1 hour, because it did have to load the database and stuff, right? But
well, you say you can say that you can do the asking folk to forgive you, but there's some weird new things that have arisen that you wouldn't have, like the new stuff of been able to live resize a pod, because apparently rescheduling a pod is now a thing that people are afraid of doing. And we're going all the way back to having like those long running pods that would have been the things that your WebLogic or whatever else would have been on. We started with a kind of more purist of like, no, if you are changing the size and the resource limits, you will need to reschedule it. Which, and like a lot of the time, like we were one of the first, and the department I was in were the largest AWS Spot instance customer, because we really embraced the virtues of the rescheduling, because it forced the apps to restart, and that was a good thing. Like embrace that like the inbuilt kind of chaos monkey that, well, worst case scenario, best case, your app's going to run for 48 hours, whatever a spot is, and then it will reschedule. But yeah, it's weird seeing that kind of go all full circle with the big enterprise customers demanding that pods should be able to resize on the demand.
Oh, I have been, I would say, away from the Kubernetes world for now 3-4 years. So it's good to hear from you some of those updates. I guess it's probably the system and the community actually adapting to what it's being used for, right? But it is from thinking about it from back in the day, and from the kind of the I guess the philosophy that you would go into it, also in terms of immutable infrastructure, and we'll just redeploy and kind of as you were saying, or reschedule it. That it's interesting to see that shift.
Yeah, it's a funny one. I guess it might encourage some folk to right size stuff in the first place, because maybe they can size things down. But we've had for some time kind of vertical pod auto scaling stuff that would look at actually what the trends were and scale the thing and reschedule it. But yeah, I just found it quite peculiar. So I only saw it in the news. I've not used it in anger yet. I don't get kind of much actual kind of my hands dirty with much of it, apart from when I do some teaching and training on it. But yeah, it's weird, kind of like, oh, okay, fine. There's another oddity in the API that it is. But I like the idea, like the philosophy of Kubernetes of basically it's not much of a thing, and as more stuff moves out of core Kubernetes, it's going more towards just a bag of API standards and schemas, where the other things are going to actually do the interface, which is an interesting kind of way of how they've kind of broken a market and a space, with leaning in, doing a lot of the heavy lifting, and then waiting for the rest of the community and industry to pick up and then fill in the schemas, which is why you'll then see some API schemas like ingress and stuff kind of fading away, because there's other more dominant ones that folk are using that are being filled by the market.
Okay. And I would actually still like to circle back to our beginning and talking about the kind of how you used it in the government services, because one thing that I would like to, so it was pretty early Kubernetes stage, right? Was it still in alpha the first time you got it running in production? So would like to know a bit, because what gave you the confidence to run it an alpha kind of new technology in government kind of production customer facing service? Because there's usually quite some demands on that side, and risks and downsides, right?
Yeah, I mean, for a series of citizen-facing applications, so open to the internet, it was both brave and stupid, but it was the betterer, right? And I'd still stand by like it's running like booting a fresh Kubernetes cluster today. It's still in the space of the betterer answer. It's not best. Ideally, you'd wish for more, but it's the best thing that we have right now. Yeah, and there's lots of bits of things that don't quite make sense. But like, yeah, most of the time works. And it was an interesting bit. I mean, at the time there was emerging, like it was very early on like you could have hand cranked with just running the containers and just like having a load of shell scripts around some containers. You could have done some other things at the time. Kubernetes wasn't probably much more for us really than a load of shell scripts really, because it was very simple with very primitives. It was before pods were a thing. It was you had replica set controllers, which is about as much as you had as a low level bit of resource. But yeah, very low level bits of primitives, the shiny things. It's often the kids don't know how lucky they've got it these days, right? The pain that was. However, you can still see the scars of that with some bits of stuff in the API that if you were to design that afresh, you wouldn't do it now. You wouldn't do it that way, where things don't quite make sense with mixes of plural and singular wording on like API schemas and all sorts of stuff like that. It just doesn't make but be consistent. But it's one of those bits of kind of legacy that we'll have to carry hopefully until maybe there's a 2.0 and maybe we actually can clean the slate and start again on some of those weird things that are knocking about.
And is there anything that you had back then that you miss now from a Kubernetes perspective?
No, I don't think so. I mean, there's a lot more tooling to do the things. So if I remember, that was long before you ended up with like kubectl exec or something to go and like look into a pod, and before like nowadays you have ephemeral containers to do that with, so you can go and do some debugging in that sort of world. Whereas at the time you were like SSHing onto one of the nodes, and then connecting through like Docker attached to actually go and look at something. So yeah, there's some more mature bits of modeling. I don't think I really long for any of those, any kind of that much pain and misery that we had then. I guess the only thing that I'd wish for would be the original kind of vision of the kind of truly deterministic kind of compute that you'd imagine, where we'd move away from like naming your mail server Bob, and when Bob breaks at whatever, then all hands to the pumps, and it's got to be fixed because the CEO can't get his email, and then big celebrations for whoever manages to revive it. And the original vision of the that kind of immutable and deterministic infrastructure has just moved up an abstraction level up to the control plane. Like I challenge and welcome, I guess, any of the listeners to comment on like the amount of times that you blow away and recreate a cluster from scratch on demand, because the majority of the time your production world has gone through a journey of upgrades that your not production world probably hasn't. So you might have done your not production world of like incremental versions, every patch version, every minor version, and then your major one, maybe your production release, you will have done kind of more major ones where it needs it, where there might be a vulnerability that you're concerned about or anything else like that. But in any case, production has very unlikely gone on the same journey through, and you'll end up with all sorts of, if you were to actually inspect it in your etcd or whatever is providing your cluster state, is going to have all sorts of weird orphaned bits of artifacts and like things knocking about in there that ultimately kind of get you to the same point of what Kubernetes was trying to solve way back when, was giving you deterministic kind of predictable environments and removing a lot of the developer saying, well, it works on my machine or it works in OpProd, and then kick it over the line to an ops team that are looking after the prod cluster, which is not much different to now how we see often when I kind of go working with organizations, you'll see the same cultural drift with, I mean, it doesn't help when you end up with DevOps being a job title or SRE or anything else like that. When the original kind of thing that it helps a lot with, whilst hurt the cognitive load, meant that the developers had a lot more kind of control and things. So you ended up with a much more in the way of you build it, you run it teams. as opposed to you build it, then you hand it over to ops, and then they'll run it in live service. They will do the patches, and then you'll always end up with a fight between an ops and a build team.
But would you see that is that more of a I see it more of a if you will, a limitation of culture and processes than necessarily a limitation of the technology, right? Would you see it?
I mean, it's the two roll around each other and orbit each other, right? So, yes, like saying, like the Kubernetes has got us a fair distance, but the cultural pushback means that you would get oddities that look like things like I don't know, like Helm, for example, which is a horrendous idea that seems to have still persisted as a technology, but culturally it's kind of fits because those two haven't managed to decouple. We've not managed to kind of fully move from kind of the desires and dreams of people doing a totalitarian control over some engineers, and you'll only have these things you can change and like configure, to what the original kind of ideal would have been, and the utopia would have been that you would have had as an engineer a quite rich environment, so very much the same level of depth and control that you get from your like local dev machine.
But then are you then telling us that we shouldn't be using Kubernetes at all? I would kind of, what is your kind of, I think would love to hear your stand. Like, are there some cases where it makes sense? Are there some cases that it's better to use something else? What's your thought on it?
So it's definitely not my first choice. Like it's the better than some answers. But yeah, if going into something greenfield, it's not going to be the hammer that I'm going to reach for to start with. I mean, don't get me wrong, I run Kube on my kind of home cluster that runs all my home automation and stuff, and like I have to deal with fixing that regularly. It inspires a lot of bike shedding fundamentally in an organization. If you're a bank or a e-commerce website or whatever your actual line of business might be, you end up having to have a operations team that are looking after the Kubernetes cluster. It's not given you the panacea that anyone was chasing. I'd always look to reach for higher order services as a business, like chase the actual business demand. So if it's look for like a SaaS solution first, and then like, okay, if you can't find any of those, or where you need to produce glue in between the SaaS and your business kind of world, then like functions as a service, and exhaust that long before you then like look to kind of platform as a service. And in that, when you get to that level, definitely don't try and run your own Kubernetes cluster on your own hardware. Still reach for kind of the managed ones that the cloud vendors will give you. Turns out they do a much better job than any of your folk can, and like Surprise. That's built into the price. Well, they have a fiduciary responsibility to their shareholders. So like, yeah, whilst there's some oddities, and you might find that you don't get all of the new shiny, exciting, sexy features immediately, or you find some constraints. Actually, though, I generally would argue that on the large kind of whole of things, those constraints are useful. Same thing as going into a restaurant, and if the menu is just, I mean, look at the CNCF landscape and how that's evolved. It used to be that you could recognize the logos because they were big enough. Now, if you go and look at the CNCF landscape, I know I've looked at it for a few months, but last time I did, it was mental. Of just the amount of tiny little, like basically like 2 or 3 pixel sized logos, which is mad. So you are just overwhelmed with choice. And if there's anything that can constrain you as if your world is not running a Kubernetes cluster, if that's not your line of business, then cool. But yeah, if you're actually trying to run an actual business or have an actual purpose, or if you're public sector or whatever you might be, that's not just running the cluster, then don't avoid all of that responsibility. And even the managed Kubernetes clusters will always be a corruption of the ideals of cloud, where the shared responsibility model put the cloud vendor on the hook for a lot of things.
Yep.
So where you can, avoid taking on responsibility. So avoid taking on responsibility for like doing your own key management, for doing your own like storage backends, for running like a service mesh over the stuff, and all of the other stuff that you can totally do. And it's all very interesting if we can all stroke our beards and look very clever whilst we mess about with it. But your future self at 4 a.m, when it's all gone wrong, will not thank you. And that will happen. I expect that to happen. That's the future thing. And if it's not in your career bit or your job there, it will be in your your successor will end up with that gift.
And do you see that sometimes that tendency to then kind of maybe stay away from, let's say, functions as a service and kind of going more towards the platform as a service, or even kind of building and running your own clusters? Do you see it as a bit of kind of people being resistant to giving control? I mean, or giving away their control, right? Do you see engineers kind of leaning more towards that? You do it all yourself because we think maybe we can do it better, or is there? How have you experienced that?
I mean, yes, and I've been certainly guilty of it in the past. And ultimately, as anyone kind of goes through their kind of probable professional career, you normally kind of get, as you get further up, you get closer to the actual business and further away from the weeds of the actual, from the code, and you can kind of see it from a different perspective. And you go, why would I try and like do that and like follow some a philosophical kind of campaign that doesn't align with the actual business? And instead, it's a bike shedding exercise where you are just investing all of the energy and time in that. But if you could repurpose those engineers to do something that's more aligned to your business, then that would be infinitely more value. And like typically, unless you're like the OpenAIs of the world with like near on infinite money, your majority constraint is people. And that's the actual ability to hire people, bring them on board, make them understand your business, vet them, do all the things, maintain them, do all the other kind of HR type stuff as an organization. That's a big investment. And if you can get more actual business value out of that, then chase that. And typically running low-level bits of compute that you could outsource to someone is probably most of the time, I'd argue. There's some cases, edge cases, but most of the time not where the business value is to be found.
And I think one component there is also the cost, right? Because I think that maybe we're not, as humans, the cost of running something managed or on kind of as a service is a very clear cost, because you see the bill and you see the number. I think there's so much kind of hidden cost if you do it yourself, right? And so I think it's usually not a apples to apples comparison, because you have a clear number here. Oh, it's expensive to run it, and then we can do it ourselves. But then you're often then not counting for all the hidden costs of people and kind of then having the incidents and having to wake up people at 4 a.m. right? So I think that's an interesting side to it as well.
Yeah, I think the main things that like frustrates me in tech is we don't quantify risk. Like other bits of the world, you'll put a price tag on stuff. So your insurance company, as an employer, you will have fundamentally there'll be a price tag on events, and then the likelihood of those events. So maybe someone getting an electric shock whilst in the office, or tripping and falling, and then the consequence of like losing a limb or losing a whatever. That has a fundamental, like, whilst you can be kind of quite saddened by the fact that there is a price tag on it, there is one. Therefore, that ratchets your premiums. And it's the same thing of going, well, I could reduce my premium by putting better locks on the doors. or I could reduce my premium by other means, right? And that provides some motivators that can lead you towards better things, like you put leak detection in and other things that an insurer might offer you as here's an investment, it will pay off over 3-5 years, whatever, by doing this. If you're going to be there for long term, do it. And we don't typically do any of that in tech at all. And if you, as you said, like any of those decisions, they carry a risk. And if you've not got to a point of kind of quantifying that, yeah, you might be fine. So 5-10 years off the life of your kind of business exercise where that Kubernetes cluster or clusters are going to live and run, it might be fine. But if you're, as a CFO or whatever, were to actually see that on the balance sheet, you might find yourself uncomfortable with the amount of risk you're carrying. And I say, quite probably, you'll be fine. But your CFO may have, and your shareholders may have a different opinion on the gamble they're willing to take. And that's a lot where that value is kind of missed and lost, particularly in tech. And that's not a thing that's specific to Kubernetes or serverless or cloud or anything. It's just generally with tech choices, they're largely made, even in big regulated organizations or public sector, typically made emotively as opposed to with any kind of real science behind the risk validation. And if it was, it's definitely not ongoing. Like, you'll do it at a point in time, but very rarely, I've never seen personally, I don't think, that repeated, and so that it is an actual continual reassurance process in order to go, well, we did our Kubernetes cluster or whatever it might be. We did that and hand cranked it and define the exit criteria of if this, then that, we will stop doing it because industry will have caught up. And that was the thing with so we were doing like Kubernetes way back when, long before Amazon were the first ones with a managed Kubernetes service, which was took a while to then become mature enough to then migrate and pivot everything over to. But it was very much like, if this, then that, we will look to migrate stuff over. And if you can do that and bed that in, then it can also kind of give you an end exit thing that can make some of your risk folk a bit more comfortable if they can understand what it is you're doing.
I see that. It's a good reminder to keep that and to keep revisiting your decisions and if they still make sense. We do love scalability, right, in this podcast. So I would actually like to go dig a little bit into that, and specific with Kubernetes. So I've heard that you've said at some point that regarding Kubernetes, if you're relying on Kubernetes autoscaling, it's already too late. So can you tell us why is that? Why do you believe that's the case?
I mean, it's not too dissimilar fundamentally from Gregor Hohpe has a comment line. I'll attribute him. He might be attributing someone else around if you've got guardrails, it's already too late by the time you hit them. What you need, and he uses lots of kind of car metaphors. So what you need is lane assist, and like the guardrails. If you even touch them, it's going to be a really bad day. What you need is very much lane assist. And so, to the point on like the auto scaling stuff, by the time that you are pushing up against it, you may find yourself in a world where it takes you too long, or there's not available capacity in your cloud provider or your physical on-prem infrastructure to be able to service your need. But that all said, like I'd made a game a while ago for a KubeCon thing, and the point I was trying to kind of get across with that, the scenario was it's a Black Friday, and you're looking after the ops. You've got to tune the cluster so that it scales up and down over a Black Friday and a Cyber Monday in order to save the most money. And the bit that I was trying to kind of articulate, although I'm not sure it necessarily really came across, was that it's okay to fail sometimes, because I come back to like, it's a business problem. If you end up with self-imposed SLA with maybe a financial penalty and a dropped connection, then you can then make an informed decision. The right answer is not always being always able to service every request, because from a business point of view, that quite possibly doesn't make sense today, and can be overkill if you are over provisioning and over scaling in order to know that you're never going to drop something. Whilst it can, as an engineering kind of thing, we can all feel very clever about that, and very proud, and we can put on our CV that we ran a cluster with so many thousand nodes or whatever. Like, cool, but business problem might not have actually have required that, and also like reference the, when you then tune any quality of service stuff, if that's a business decision, not really a technical decision of, well, what is the more important thing to run? If you end up running out of physical compute capacity of what you can lay your hands on quickly, recognizing like if you're in cloud, then best case scenario, you're a few minutes away, if the compute's available, from being able to boot up a machine to then start your container running it, to then have data running on it, to like anything else, or database replication, like all of those things, that's time. The right answer is not necessarily to always be able to be kind of to be able to service it, and there's a business and a risk and a financial choice behind that. And yeah, if you can put a price tag of a SLA impact on your platform team, and like, here's your objectives quite clearly, not just a don't drop a packet. It's a, well, here's your budgets, and here's here's what we're going to cut from your budget when you mess these things up.
Yeah, and so, and with your game, was there a right answer? So if anyone was then playing your game, what do you think was the right strategy there?
I mean, looking at the scoreboard of the people that did play it, I think they were giving away. So I built it for a company called Appvia, and they were giving away Oculus Quest or something. So, or a few of them at KubeCon. So consequently, got a reasonable amount of attention, as you'd imagine. It was a sweet spot, which did mean dropping some requests. So, like, looking at the scoreboard and how people played it, that you can't just turn everything off. That's not the cheapest. That doesn't get you the best score. And it's also not always been able to handle all the requests, but there is a line where you just go, well, this actually makes this is the cheapest to the business as an operational cost of running a thing to run your Black Friday. Here is the end kind of state where we make the most profit as a business.
Yeah, and I know I'm extremely biased here, but then I was thinking, I would love to play that game, but only if I would be allowed to get a virtual waiting room in front of it and doing a little bit of a traffic orchestration there. But I don't know if that was. I have no idea if that was allowed in the game. Probably not. But I would also.
No, I mean, again, like, it comes back to how you mitigate the thing, and yeah, if you can offload onto something or show an error page that has a graceful message on it, or has any sort of things you could mitigate some of that. This was entirely intended to be a very crude penalty of like, yes, you've dropped the request, therefore the business side would like to fine you an SLA fee.
I think one thing that comes to mind on my side is more around, and I think you did mention chaos engineering somewhere. I think that the kind of that idea of, well, we do some autoscaling, but if we cannot make it, at the very least, let's try to have some graceful degradation of the service, right? And some of those cases, like with Netflix showing you an alternative list of shows if the service is not responding, right? I think that's quite a good kind of balance between, okay, we do try to have some auto-scaling in place and the ability to grow with the request, but if we cannot, what is then a good alternative?
Yeah, well, as long as you don't have like a reverse exponential back off, then you're probably fine, right? I guess, yeah, it's super, like, yeah, the business side of the degraded approach, and where that might not like do everything and might not be the best experience, but you're still able to retain your customer, you're still able to engage them, do something with them, then that's great. And the more that you can do that, the better, and then cascade your graceful degradation all the way up the stack. So if your database is failing, make sure the middleware doesn't just smash the database into a sense that it will never recover. floats a message up through the stack so that you can present your user with like the end human being, because most of the time we've still got human beings driving stuff today, at least
For now,
but actually for the minute this week you can float that up all the way to the end user, your customer, or whatever,
or their agent,
or their agent, or whatever, and kind of give them a meaningful thing that is not just here's a 500 error, don't know why, like find out, but something more engaging, and then if you can find inventive ways to retain them as a customer if they're particularly disenchanted, then all the better, right?
You've done quite a lot of work with government, right? And is there anything any patterns specifically there that you see that make things hard to scale? Any specific constraints that you've seen?
Mostly myths. Myths mostly. So UK governments, we were one of, if not the first, to have a cloud first policy. So for central gov, and highly encouraged for the rest of public sector, where there is a kind of mandate to fully exhaust the option of using public cloud before you do other things, apart from higher classification tiers. So not applicable for secret and top secret, but for anything that we refer as official, which is the vast majority of any normal kind of operations, you should fully exhaust running on public cloud. There's a number of organizations, as always there will be convinced that they're a special snowflake and it doesn't apply to them, or for their weird edge use case, often kindly, often like lacking the perspective of that every bit of government or every bit of any organization is unique, because otherwise it wouldn't exist. So everyone's a special snowflake. Everyone's nuanced, because otherwise if it wasn't nuanced and unique, then it shouldn't exist. So some beliefs around that, beliefs around use the horrible sovereignty word of presumptions of data sovereignty being interchangeable with, or digital sovereignty being interchangeable with data residency, and like those are not the same, but believing that we could only possibly host services or host any data in, say, UK data centers. Similarly, like I've seen other businesses do similar things, and argue like there are, as we're seeing kind of play out in some of the courts and some stuff, like there is very little real reason for doing that. And you'll typically find, certainly at least in the UK, hosting stuff here is the most expensive and the least sustainable most of the time route to doing stuff. And the arguments of latency are pretty minimal these days. Like you're unlikely to notice much of a lag from the vast majority of stuff to kind of cross over the Atlantic. It makes no odds. But still, we see a lot of organizations and businesses reaching for deploying stuff locally, and picking London as a region. And then similarly, I've seen other things in other, when I've dealt with kind of companies in other countries, they'll pick the nearest one instinctively, not really fully thinking it through and not looking at the actual cost comparison and risk impact. And to a scaling point, that fundamentally just means that you are limited by that, and it's interesting to see how like the cloud vendors also reflect this sort of maturity in the demand side by the lack of progression. Like we see there's not many global services. We have not moved dramatically in Kubernetes or anything else is kind of a part of this space, but we've not moved dramatically far from somebody else's computer a lot of the time. So you are still typically deploying to a zone that's in a region, that's in a cloud vendor, and often to a node that's in a zone and thing. Like even if you're using a managed service, you're still aware of zones as a primitive, and still probably aware of nodes of actual compute. And then you take a provider like Cloudflare, where Cloudflare will give you you deploy to the world.
Yep.
Which is and that's your only real option. You can exclude some regions potentially, but you are deploying to the world, and that's a very different paradigm to work with, which is different and very different perspective to what the other hyperscalers are doing. And frustratingly, they seem to be generally quite quiet about that and haven't found a way to market that as much as I'd kind of wish for them to, and celebrate them for it. That it is a very different paradigm. But even they've, I haven't spoken to them that much about it, but they seem to have kind of compromised on some of their original philosophies of like, you've got a WASM container and a thing. Now they've started kind of fallen back on some of the early kind of purist philosophy, and then you can now do normal classic, I think they call them containers. But you were in a world where if you were doing like WASM containers, meant that you didn't care about the CPU architecture. It would run an ARM or a PowerPC or a x86 or whatever. Not your problem. As an engineer, I want my application to run. I shouldn't most of the time want to care about the CPU architecture as long as it compiles and runs. So just run it in the cheapest, most sustainable, fastest way somewhere on the planet that's hopefully going to be near to my end user. And delegating that entirely to your provider is really fortuitous. But yeah, it's back to your kind of original question on like the things that things go wrong is a lot of that, the myths and the thing that like, oh, we couldn't possibly do that because something that might have been true maybe at one point is not regularly reevaluated and needs a fresh and like, actually, is this still true? And actually really evaluate that against business demands and what's right for the organization. And I know that we're getting close to the end, and we do have a few quick fire, rapid fire questions to wrap up. But before we get there, so in the work on the government side, do you still see a lot of legacy systems there, or I guess you were saying that there's a cloud first policy in the UK government, right? But then do you still see a lot of the legacy systems sticking around? So credit to some of the folk in one of the teams that I work with. They published early last year, what was called the State of Digital Government Review. It's the very short abridged. It's an interesting read, and there's a lot of stuff in it actually, whether you're UK government, a UK citizen or otherwise, but as a very honest publication. It's really fascinating to see that scale of problem space of technology, and the very abridged is that they'd identified was it £45 billion of GBP of annual savings that could be realised if we were to transform and address that. So that is that's the operational day-to-day in the UK public sector run cost of legacy, and that's obviously like what they'd spent. And whilst we do have a cloud first policy, and I'm so grateful for that existing, because it removes a lot of choice and decision, and it's further cemented with language that is services, not servers. So again, like look for the higher order services. Don't just look for some low level compute. Go for your SaaS. Go for and go up the stack as far as you can. Nice. So yeah, whilst all that's great, there is still plenty of legacy, and it would be naive and like new legacy, as in legacy being built in cloud, or where we've lift and shifted and not quite concluded a strangler pattern, because like we have some bits where there'll be a data center exit and there will be contractual or sometimes physical requirements that you just need to move it. And then public money, same as any kind of large organization enterprise, may not come for the actual the rework, and that's always a thing that's kind of the can that's kicked down the road, and you don't ever kind of get round to the full kind of rebuild that you really kind of wanted, or any of the people kind of committed to. Of, we're going to do this now, and in 3 months' time we're going to completely re-engineer it and make it better. There more often than not that doesn't come about, because I come back to think there are very few people that are actually technically competent that you can get, certainly in public sector, with the amount of money that public sector and government will pay people. Very little that you can actually do. Your resource constrained more than anything else, and there'll be other things that actually, quite rightly so, were probably more important. If you had infinite human resource, it's not typically a shortage of money. It's mostly the human beings. But if you had infinite human resource, then the whole thing would be a lot better, and we'd save tons of money. But the amount of people that I would personally trust, to go and produce a cloud landing zone architecture and run that into an organization is maybe 10, 12 out of thousands of people I've ever spoken to, that I'd actually go, I'd vouch for them to do a good enough job, and that might meet some organizational needs and might not just create further ongoing technical debt. So getting to the rapid fire questions now, just 3. You don't have to, don't overthink it. You can just share what comes to mind. So the first one is maybe the more complex one. So do you have any suggestion or tips or guidance if there's someone out there getting ready to start some new platform for critical infrastructure? Focus on the business problem. The higher up a technical stack you go, where you can offload as much responsibility onto a vendor provider that it's their day job to provide the stability, the better, because you are inevitably limited with human resource. You don't have all the capacity to run all of the stack. Don't try to. You won't do a better job. Accept the limitations and some of the constraints that are present, and focus on the business problem that's at the very tippity top of the actual stack, and just go for some tried, tested, boring technology beneath it. So probably not AI most of the time.
Awesome. Thank you. Is there any book or thought leader or blog, podcast that you recommend?
Acquired as a podcast, very long form stories that will ground you in the reasons why business things happen, as in an actual scale of things, and they're fantastic, really, really well curated stories that they put together. Gregor Hohpe's with the Architect Elevator, I think it's called, but he's got a few books. They're all fantastic. Simon Wardley with kind of Wardley mapping. It's a personal friend of mine. He's fantastic. And will change the ways that you think about stuff, particularly with some of the technical choices that you look at, and has got some fascinating stories. He's has all the war wounds from early bits of cloud and infrastructure as a service behind him in a lot of his stories, and can produce a very articulate narrative around when to build versus buy, fundamentally. Which, when you're looking at particularly scaling or any kind of building of something that might be critical national infrastructure, is really important to kind of factor that in.
Awesome. Thank you. Last question. To you, scalability is?
Resilience.
There we go. Short and crisp. Thank you so much for you being here, Chris. It was wonderful talking to you. Thank you.
Thanks so much. Thanks for having me.
And that's it for this episode of the Smooth Scaling Podcast. Thank you so much for listening. If you enjoyed, consider subscribing and perhaps share it with a friend or colleague. If you want to share any thoughts or comments with us, send them to smoothscaling@kiwi.com. This podcast is researched by Joseph Thwaites, produced by Perseo Mandilo, and brought to you by Qt, your virtual waiting room partner. I'm your host, José Quaresma. Until next time, keep it smooth, keep it scalable.